Okay, on number 8, if you read the problem, it says that we have a $10 delivery charge. So we're going to rework the problems that we did previously. We're still going to have the $9 per pizza. You can still spend at most $175. But we have that flat fee of $10 for delivery. So on 8, they're asking us to write an equation that describes the cost, C, of buying P pizzas with the delivery charge added. So our cost was C, and we're buying P pizzas, and they were $9 each, so 9P, that's the cost of all the pizzas. But now you have a $10 delivery charge. So they now want us to complete the table, then use it to estimate the number of pizzas you can buy. So why don't you pause this and fill out the table. Okay, hopefully our numbers match here, and maybe we're seeing the same thing, that still you'll only be able to get between 15 and 20 pizzas. Surely we can do a little bit better than that as far as exactness. Okay, the number 10 asks us to use the information from the table to draw a graph with the number of pizzas on the x-axis and the total cost on the y-axis. So let's go ahead and use the same skill that we did before. So I think we did 5, 10, 15, 20, 25, 30, and I think we're kind of happy with that. And then for the cost, we did 50, I can hardly see that on here, 100, 150, 200, 250, 300, 350, 400. Okay, so I'm going to go ahead and let's both pause this and plot the points. Okay, so on number 10, I went ahead and plotted those points, and I always also use the graph to estimate the solution to the problem. Well, clearly, again, it's going to be between 15 and 20, and I don't know, it looks to me that'll be closer to 20. All right, let's see what else they have for us. So in 11, they asked us to write and solve an inequality that can be used to find the number of pizzas you could buy with the delivery charge added. So remember, it was at most $175 that we could spend. And then the equation we had was 9P plus 10. All right, so let's go ahead and solve this. So I have 9P is less than or equal to 165. Let's divide both sides by 9. And I get P is less than or equal to roughly 18.3. So it looks like you can buy at most 18 pizzas with $175. So number 12 says, in this situation, would you say that the cost of ordering pizza varies directly with the number of pizzas? Explain. So we're going to say no on this case. I'm trying to find the original. Sorry about that. So your formula was originally C equals 9P. If we had stopped right there, we could say yes. But when you put plus 10 there, that means no. Why? Because it's not in the form, of y equals kx. Okay? So again, if we just had this part right here, C equals 9P, that would be direct variation. But when you have a y-intercept of anything other than the 10, then no, it's not direct variation. Okay, so 13 asks us, what is the slope of the line that you drew and what does it represent? Well, I think some of you can guess that it's probably going to be 9 again, and you're going to be right. I'm going to go ahead and use 2 sets of points from number 9. Move this up just a tad, okay? And so I am going to use 0, 10, and 5, 55. So we have m equals 55 minus 10, that's your difference in y's, over 5 minus 0, that's your difference in x's. So again, we have 45 divided by 5, which is 9. And so once again, this should not be a shock to us, right? We have a slope of 9, and so that represents the price per pizza. And then they ask, what is the y-intercept of the line you drew? Remember, the y-intercept always starts with 0. And so our y-intercept is 0, 10. And what does it represent? Well, we're going to say that this is the $10 delivery charge. So once you order the pizza, you're starting with $10, and then it's gonna, your price or cost is gonna go up depending on how many pizzas that you buy. Okay, let's take a moment to look at the did you get it? It says you can't have the family choke down 13 hot dogs with nothing to drink. If you need to spend $18 on drinks, write a new equation that describes the cost of buying 8 hot dogs. So I had to go back and figure out how much the hot dogs cost. So our cost was going to be $1.50 times H, and then plus 18 you spent on drinks. So that's your total cost. And this is what was the slope and the y-intercept of your equation. So on 4, our slope would have been the $1.50, which was our cost per hot dogs. And our y-intercept would be 0.18, and that's the amount that we spent on drinks. Okay, back to number 15. It says look back at your answers to questions 8. So our answer on question 8 was, see, let me make sure I've got my pencil. Yeah, was C equals 10 plus 9p. And then 13, we said our slope was 9, and 14, we said our y-intercept was 0, 10. So I hope can figure out that the slope was 9, the y-intercept was 0, 10, and our equation was C equals 10 plus 9p. I want to point out we could have also written this as 9p plus 10 there. So this fits the form of many of the linear models that we've studied previously, where the equation was a form y equals the starting value of the quantity, that's what we have up here, 10, plus the constant rate of change, 9, times x. Remember, starting value means the output associated with the input 0. In algebra, we call this the slope-intercept form of a line because the two constants in the equation are the slope, rate of change, and the y-intercept, starting value. The slope-intercept form is usually written as y equals mx plus b. That's why I said we could have written this like that. But it also can be written as y equals b plus mx to match the order that we've been using. So when a line has a slope m and the second coordinate of its y-intercept is the number b, then the equation of that line equals y equals mx plus b.